Welcome to this Frequency Matters podcast. I'm Pat Hindle, and today I'm talking with Jürgen Meyer, Vice President of Automotive Market Segment at Rohde and Schwarz. Welcome, Jürgen.
Hi, Patrick. Great to meet you again.
Rohde and Schwarz recently opened a new, larger office in Osaki, Japan. It has increased capabilities, including some interesting demos. So I thought it'd be great to cover this in the podcast. And so maybe you can start off by telling us, why you decided to expand there, and what are some of the unique demos that are on display there?
So Japan is a growth area for Rohde and Schwarz. Yeah, we can win market share there by just enhancing our capabilities. And this is for all markets. But of course, we also see a big chance then to grow in automotive because compared to other countries of the world, our market share in Japan is still pretty low. Yeah, and that's why the company in general decided to open a new office with more space. And of course, for automotive, that's a great thing because that allows us to also integrate some of the solutions we have, like now the service center for service, repair, and calibration is at the same location as our sales force. We have more office space. There we can host bigger customer events. Yeah, and all that helps us to deliver an innovation advantage to our customers who work with us. Yeah, because we can also use that space to cooperate with partners like IPG or AIP, who help us to offer a total solution to the market.
Speaking of AIP, you have a test system that combines EMC receivers and automation software from Rohde and Schwarz, and you do that with AIP. How does this system work, and what kind of measurements can you make there?
So today, this world, at least in some areas of the world, goes battery electric. Yeah, and when you have battery electric cars, then the inverters of that battery electric cars, they're a real big challenge for EMC conformance. So in the past, in EMC, we were testing the vehicles on constant speed. And with the battery electric cars, this is no more representative, because these cars, they have different behavior. When you accelerate, maybe a second engine will start, or if you brake, then recuperation stores the energy in the batteries, so different states. And these different states, we call them the dynamic road scenarios, they need to be performed during the EMC measurement. So we have implemented this functionality at first with AVL in 2022, and now AIP, which also offer these roller test beds, they have adapted their software, which controls their chassis dyno, and we have connected their control software to our EMC software, which is called Electra, to perform these more complicated tests.
So you mentioned that EMC is a big issue. What are some of the latest challenges you're seeing in the area of automotive EMC?
Well, the problem is that it is unclear at which frequencies these dynamic road scenarios generate the EMC issue. So that's why we have developed test receivers with a very high bandwidth to detect the possible problems as fast as possible. So here we have the Rohde and Schwarz ESW with the B1000 options, which offers 1 gigahertz of bandwidth. And therefore, this product is very appreciated by our customer because it speeds up those very complicated tests. Yeah. And that's why we also see that more and more customers now invest into reverberation chambers. That's also a new technology that allows us to detect very fast whether a vehicle has EMC issues or not. But if yes, then you need to find the root cause of the problem. And today, this is easier done in standard Ulcer chambers. So the new approaches have to be developed in order to debug the vehicle in reverberation chambers. There are ideas how to do that, but the technology is at the beginning and it's a big topic for future innovation for us and also for our customers.
And so Rohde and Schwarz is further expanding its collaboration with Granite River Labs and Analog Devices to support in-vehicle network compliance testing in Japan. Can you tell us about those collaborations and what you're doing there?
Yeah, very good question. So I think it's clear that you have more and more cameras in the vehicle. And also there is a new technology which is called satellite radars. And the cameras and the satellite radars, they need to be connected to central computers. And you need a lot of bandwidth in one direction. Yeah. So, and just a small control channel in the other direction. So we call that asymmetric in-vehicle networks. And as explained, asymmetric means a large communication capacity in one direction to transfer the video and the satellite data, and a small control channel in the other direction. And in 2025, Analog Devices, they opened their technology for that one. It's now called Open Gigabit Multimedia Serial Link. The abbreviation is GMSL. So the open version is now called Open GMSL. And that is a technology where now second source silicon is already available. And when you have chip sets from different vendors, you need to make sure that they work together. This is done by compliance tests. And Granite River Labs, they have developed test routines based on Rohde and Schwarz instruments like our oscilloscopes and vector network analyzers. And the Japanese market is very much interested in that open GMSL technology.
And I saw that IPG Automotive partners with Rohde and Schwarz also to integrate automotive radar hardware in the loop testing, or Hill. And so what kind of testing does this facilitate?
So IPG, they are the market leader for environment emulation and vehicle dynamics. And they offer testing of sensor fusion, where cameras, radars, and GNSS need to simultaneously be tested. And Rohde and Schwarz, we contribute with our instruments for the stimulation of GNSS and radars. So this allows to bring tests, the so-called hardware in the loop tests, from the road to the lab. So this technology then offers better reproducibility of these tests for lower cost, because you can imagine prototype cars on proving grounds that has a big problem with cost, because these cars are very expensive, and the driver, they run maneuvers which are not reproducible, or it's very hard that this is reproducible. So that's why the hardware in the loop technology that we offer together with IPG has a growing interest.
And the automotive industry is actively exploring non-terrestrial networks, or NTN, to provide ubiquitous wireless connectivity for always connected vehicles. What kind of testing are you doing in that area, and who are your partners that you're working with?
So modern telematic control units, they need to outperform a cell phone hotspot. The buyers of a telematic control unit in a car, they expect better throughput and coverage, and the coverage also in rural areas. And in rural areas, we all know that standard base station communication very often does not work. So you need to have that satellite communication, and that is called non-terrestrial networks, and this is now under development. So these non-terrestrial networks, of course, they require new antenna designs, as the vehicle needs to be connected to the terrestrial base station for the urban areas, and also for the satellites in the rural areas. Out of cost reasons, yeah, this all shall be achieved using the same antennas. So based on Rohde and Schwarz radio communication testers, we offer antenna testing at simulation, component, and vehicle level to make sure that there is a seamless handover from terrestrial network to non-terrestrial networks. So this allows then excellent throughput to enjoy movie streaming and watching of movies in self-driving vehicles, or Maybe you want to use the self-driving vehicle as a rolling office and join a team session or a Zoom session like we are doing it right now. Yeah. So we are working with partners like IMST for the simulation part and MVG for the component and full vehicle test.
Yeah, I just came from the satellite show, and that was a big topic there, integrating satellite communications into the mobile network so it's seamless for everybody for direct-to-device connections and also IoT. So a lot of future developments there. So speaking of the future, what future testing challenges do you see ahead in the automotive market and other areas? How is Rohde and Schwarz working towards solutions to these new challenges?
So today, everybody in automotive talks about the so-called software-defined vehicle. That means basically that the OEMs need to reuse the software in different car lines. And that's why they work closer with chip suppliers to reuse the software. And that means that for Rohde and Schwarz, it becomes even more important to be more intimate with the chip suppliers. And this closer cooperation between the OEMs and the chip suppliers is very often called the shift left. That is supported by front loading with digital twins. And as I mentioned before, for us, that means we have to get even more intimate with the chip suppliers. They ask us to develop A and B sample developments, so we support them for that. And then they're also asked to how a production test system should look like, which is then optimized for throughput in production. And the whole situation there that requires that new players like Foxconn or WNC or other electronic manufacturers, suppliers who now enter the automotive market, that they are supported in the best way possible. And doing so, we deliver an innovation advantage to all of our customers.
Well, excellent. Thank you so much, Jürgen, for talking with me today about the new capabilities and demos in this expanded office in Japan. I'm sure you're going to be successful in penetrating the market even more. To our audience, you can find more podcasts at podcast.microwavejournal.com. Thanks for listening.